Welcome to the Physics Behind Iron Man by Katie Cecil, Amber Esser, and Nicole Lassen. In the first Iron Man movie, we see Tony Stark escape the cave in which he was held captive. He escaped by inventing the Iron Man suit. He escaped the cave guns blazing and took flight. While in midair, he lost power and began his freefall into the desert sand. This is where we begin to analyze the physics in the movie. Would Tony Stark actually have survived this crash landing in the desert? Let's take a look at the movie.
To see if Tony Stark would have survived this fall, we calculated the force of his impact on the ground. Force is found by multiplying the mass of an object by its acceleration. So we looked up Robert Downey Jr.'s mass and found it to be about 150 pounds, or 68.18 kilograms. We also looked up an estimated mass of his suit and found it to be 215 pounds, or 97.73 kilograms. These two combined form a total of 165.91 kilograms for the mass of the falling Iron Man. Determining his acceleration was a little trickier. Acceleration is the change in speed over time. Iron Man was free-falling for about 5 seconds. This means his velocity would have been 49.05 meters per second. The instantaneous velocity of a free-falling object is found by multiplying the acceleration due to gravity, which is 9.81 meters per second squared, by the amount of time spent free-falling, in this case, 5 seconds, to get an instantaneous velocity of 49.05 meters per second. Now remember, acceleration is a change in velocity over a period of time. Iron Man went from 49.05 meters per second to 0 meters per second in about half a second. So the acceleration would be 49.05 meters per second minus 0 meters per second divided by half a second to get 98.1 meters per second squared. Now, the force of the combined mass, which was 165.91 kilograms, multiplied by the acceleration, which is 98.1 meters per second, gives us a force of 16,275.771 newtons. Now, would this kill him? Well, we found that it would take about 18 Gs to kill him. 1 G would be equal to Tony Stark's mass, which was 68.18 kilograms, multiplied by the force of gravity, which is 9.81 meters per second squared, to get 668.84581 newtons. Now, divide the force he actually experiences, the 16,275.771 newtons, by the force of 1 G, which is 668.8458 newtons, to get 24.334 Gs. This is more than enough to kill Tony Stark.
The next scene we decided to analyze was also in the first Iron Man movie, when Tony took the Mark II for a test flight. He flew up until the ice buildup caused him to lose power and freefall until the ice melted. Would the ice really have melted fast enough for Tony to regain power before crash landing once again? Let's take a look at this scene from the movie.
Alright, let's see what this thing can do. What's SR-71's record?
The altitude record for fixed-wing flight is 85,000 feet, sir.
Records are made to be broken. Come on!
Sir, there is a potentially fatal buildup of ice occurring.
Go on! Higher! The ice stop, Jarvis! Deploy flaps! Jarvis! Come on, we gotta break the ice!
In the movie, when Tony reached the highest point, Jarvis told him that he was about 85,000 feet above the ground. This is the same as 25,908 meters, or 25.9 kilometers. At this point, there is ice buildup on the suit, and Tony begins his freefall. Now here's where we have to make an assumption. If we want to know what temperature it is in the air, we have to know a ground temperature. For the purpose of this analysis, we assume this temperature to be 65 degrees Fahrenheit, or 18 1/3 degrees Celsius. To find the temperature of the air around Tony Stark, we knew that the temperature decreases 10 degrees Celsius with an increase of 1 kilometer in altitude. So, Tony is currently 25.9 kilometers above the ground. Multiply that by 10 degrees Celsius per kilometer to find that the temperature of the air around him is 259 degrees Celsius lower than it is on the ground. This means that the air around him is negative 240.75 degrees Celsius. When he begins his descent, he free falls for 23 seconds before he regains power. So we need to know his new altitude. To find this, we take his initial altitude and subtract the distance he fell. To find the distance of his free fall, you take half of the acceleration of gravity, which will be the 9.81 meters per second squared, multiplied by the time squared, in this case, the 23 seconds, for the distance of 2,594.81 meters. So his new altitude is 25,908 meters minus 2,594.81 meters. And this will be equal to 23,313.2 meters. So the temperature at this altitude would be 10 degrees Celsius times 23.3 kilometers to equal 233 degrees Celsius. Lower than on the ground, which means the temperature is only negative 214.8 degrees Celsius. Assuming the suit itself did not give off any heat, the ice would not melt until 0 degrees Celsius, so Iron Man would still be frozen and falling to the earth when the movie shows him thawed out and regaining power.
Next, we decided to analyze Tony Stark's ability to fly in his suit. Would the arc reactor be able to provide enough power for Tony Stark to fly while in the suit? Let's take a look at another clip from the first Iron Man movie.
Hello.
Tony,
Who's this?
it's Rhodes.
Sorry, hello?
I said it's Rhodes.
Speak up, please.
When the hell is that noise?
Oh yeah, I'm driving the top down.
Yeah, well, I need your help right now.
It's funny how that works, huh?
Yeah, speaking of funny, we've got a weapons depot that was just blown up a few clicks from where you were being held captive.
Well, that's a hot spot. Sounds like someone stepped in and did your job for you.
Why do you sound out of breath, Tony?
I'm not. I was just jogging in the
I
canyon.
thought you were driving.
Right, I was driving to the canyon where I'm gonna jog.
You sure you don't have any tech in that area I should know about?
Nope. Bogey spotted!
Whiplash, come in hot.
Okay, good, because I'm staring at one right now and it's about to be blown to Kingdom Come.
Ah, that's my exit.
Ballroom, this is Whiplash 1. I've got the bogey in my sights.
Whiplash 1, what is it?
I've got no idea.
You have radio contact.
Non-responsive, sir.
Then you are clear to engage.
Hit it. Bogey just went supersonic. I got a lock.
Inbound missile.
To figure this out, we need to know the amount of power or watts it would take to fly. Watts equaling joules per second. This means we need to find joules. Joules equals force times distance, and force equals mass times acceleration. We already have the combined mass of Tony and his suit from a previous problem as 165.91 kilograms. To figure out his acceleration, we need to make some assumptions. In this clip, Tony gets from a speed of 0 meters per second to a speed just faster than the speed of sound in about 6 seconds. So he would be going from 0 meters per second to about 343 meters per second in approximately 6 seconds. So we take 343 meters per second, subtract 0 meters per second, divided by 6 seconds to equal 57.167 meters per second. So the force equals 165.91 kilograms times 57.167 meters per second squared, equaling 9,484.52 newtons. So joules equals 9,484.52 newtons multiplied by the distance he travels. Here we have to make another assumption. We have no way of knowing how far he traveled, so we assumed he traveled 300 meters. So 9,484.52 newtons times 300 meters equals 2,845,356.5 joules. Now we need to get to watts by dividing joules by 6 seconds. To get 474,226.1 watts. This is the power required for Tony to fly, and in the movie Tony states that the arc reactor can produce 3 gigawatts. If the arc reactor could actually produce this amount of power, Tony as Iron Man could actually fly. Now let's expand on this to see if Tony could actually fly with pepper pots. To figure this out, we would simply need to increase the mass and repeat what we did for Tony being able to fly. We just need to add Pepper's mass, which we found to be 60 kilograms, so the total mass is now 225.91 kilograms. So we need to find the force again by multiplying the acceleration, 57.167 meters per second squared, by the mass, 225.91 kilograms, to get 12,914.6 newtons. Then multiply this by the assumed distance of 300 meters to get 3,874,379.1 joules. Then divide this by 6 seconds to get 645,729.85 watts, which the arc reactor could power if it could produce 3 gigawatts.
Finally, we wanted to see if it was possible for the arc reactor to produce the 3 gigawatts of power that Tony Stark says it can. Let's take a look.
That doesn't look like a Jericho missile.
That's because it's a miniaturized arc reactor. We got a big one powering my factory at home. Should keep the shrapnel out of my heart.
But what could it generate?
If my math is right, and it always is, 3 gigajoules per second.
That could run your heart for 50 lifetimes.
Yeah. Or something big for 15 minutes.
If all of the energy contained in the mass of the arc reactor was converted to usable power, would it be at least 3 gigawatts? Well, energy equals mass times the speed of light squared. We had to assume a mass of the arc reactor, which we said was half a kilogram. Multiply that by the speed of light squared, or 2.998 times 10 to the 8th meters per second squared. And you get 4.5 times 10 to the 6 watts second, which is plenty more than 3 gigawatts. So it is possible for the arc reactor to produce 3 gigawatts of power. Thanks for watching us analyze Iron Man. We hope you learned something.
Yeah, okay. Yeah. The truth is, I am Iron Man.